Okay, hi everyone, I'm Shay. What I want to talk about today, why it might interest you, is what to do when you want to build cool, scalable ML systems, maybe not extremely new ones, but you want to build your own, but you don't have a strong infra and R&D team to back it. But it doesn't mean you don't have it in your organization, might mean you're not getting the attention and resources you need. And I can add also, you might not have senior data engineers and analysts and data scientists in your team. And that's my story today on how I try to help one of my clients deal with that. So I'll give the context, the motivation of the process we went through, the constraints we had, and then an overview of the process and some of the core maybe components or approaches or tools that help us achieve the result. And I'll tell you the happy ending, and I'll make it a bit happier than it is, but it's a good story. So the context, the company, one of my clients, I'm not gonna tell the exact details, but it's basically either think of it as a B2C or a B2B for very small businesses, many of them one-person businesses. The users get a store for their clients to use, so our revenue comes both from subscriptions and from store sales of our clients. It has hundreds of thousands of users, a lot of traction in most of the tractions in the States, in Europe, a lot of data. Some of it is, even the metadata and non-image data is heavy, a lot of videos and images, but we don't touch those a lot. I come and help the BI/data science team. It has an AI team somewhere, it has an R&D, we'll talk about it. The format is something I do with a lot of clients. I call myself a holistic data science consulting. I work with teams usually half a day a week or a day a week for long stretches of time, a year or two, maybe sometimes 3 years, and I help out with everything, methodology, tools, mentoring, theory, everything, you name it. Recruiting, a lot. I headed a few data science teams at startups. I guided a lot, so I've been doing this for around 10 years, and that's kind of my expertise. So what was the motivation? I'm gonna go through these quickly and you'll get the slides so I gotta run through some of the stuffs. I think kind of natural or trivial. We come in a stage where a lot of clients or users in company, in-house users use dashboards, reports, ad hoc analysis, and rely on it daily, weekly, quarterly, yearly, C titles, and we want to maintain this, but it's starting not to work well for the scale of the data in runtimes and crashes, and you'll see soon why. We have a huge white label client who want to get the same thing our marketing teams and C-levels get, but we don't know how to provide the same thing to the white label clients who gets the same system, their own business data, basically. And we're coming at a stage where all the in-house users and other parts of the company are starting to demand machine learning capabilities from the BI and data science team, or the BI up until now, and they want to see, detecting fraudulent users and detecting anomalous trends and forecasting of various things, the churn predictions and financial metrics, etc., and optimizing cloud costs, things using various tools, time series prediction, forecasting. They don't know they're asking for it, but they understand they need some kind of ML capability. So we also want to rebuild a system that can do the same thing in high scale, can provide the same thing for a white label client, and we want to have it as a foundation for building scalable ML tools. Okay, but we have some constraints. The team, the support, or the non-existent support from R&D, the current systems, and the requirements of the outputs. So the team, we have one junior data engineer and one junior BI analyst. Both are people who, this is their first position, working there for 6 months. One of them has a degree in economics, so this is like introducing into Python, and the other has a degree in computer science. And so both basically don't have any kind of experience with real projects. We have a big R&D team that works on Azure, on a C# backend architecture, nobody ever did data engineering that is ML or analytics oriented. They're not interested in learning it, how to do it. They don't want to write, and they're sure as hell not going to own a whole data architecture for BI data science, basically. But we do get a credit card. And the current BI system, there's a MySQL server that takes data from the actual production data and has its own BI stuff. And there's a cron job of C# scripts going up every week on the MySQL server. So it's starting to choke up. It's undocumented. There's one guy wrote it 4 years ago. He would go online in Zoom and add some stuff once in a while, and he's unavailable. So this is also tough. And everybody, of course, expects for everything to be the same or better. So we need the dashboards and reports and everything existing now to just keep working. It can't look different. It's got to be correct or correcter. So that's also a constraint. So this is an overview of the process. I'm not going to, a lot of it is trivial, I think. I just want to stress out the things I think are good or important in the process. Okay, we did a review. I learned the pains of the system, etc. At one point, we decided on a solution. First thing is to do feature freeze for the old systems. And when I mean features are any kind of product of the team, so dashboards, reports, analytics, we don't create new ones. We just say, okay, what's working now is going to keep working. We're not producing, we're not adding, because it would be daily and weekly basis, people adding reports and kind of algorithmic stuff that are expressed as a dashboard or a report, etc. We're doing feature freeze for us. We asked, I think, for 2 or 3 months. It took 4, which I don't think it's a really small error in estimation of just, we're not going to do anything new. We're going to focus on re-implementation and writing the new system. And we have these 2 systems running side by side where we really wanted not to put new features while building new systems. We had to. So basically, we're kind of some of the stuff we're deploying over the new system, people still using end products that sit atop of the old systems. And then we have a process of, we'll talk about it a bit more, of a lot of checks to get a sign-off by everyone that the new stuff is actually better, same or better, so you can deprecate the old stuff. Then we have a deprecation period where things still, some of them sit on top of the old system, and then at one point, 7 months after starting, we can terminate it. And also, so things I want to stress is the feature freeze, which is important. That if you add new features, it might be better to add them to the new system, even if it's still finicky. And I do think it was important that we migrated essential before launch and really insisted on launching with only the essential migrated. And then for a period, some components that were usable were used over the old system. And then we migrated residuals while at the same time pushing new features, because you can get more mandate or time. People don't have a lot of patience. You got to show the new system is working, you're delivering. So I do recommend, kind of, if you're doing the same thing, choosing well the essentials, and then don't expect to have 3 more months to work on infrastructure and closing technical debt. Keep, one thing is doing both, and another nice trick is you keep, when people ask for new stuff, you say, okay, but the report or dashboard or thing you want to have this new feature, it's still in the new system. So you estimate into the project of the new feature the migration into the new system. So you kind of like hide the cost in a way, because you can get away with a lot of infrastructure costs. Okay, we're good on time. So basically, I don't want to go into everything here. We start from the goals for the company and then for the team, and outline the strategy and survey the tools and demoed. And then we designed basically a modern data lakehouse. We'll talk about a bit. I'm not a data engineering expert, about the 4-tiered medallion architecture, tendency baked in because of a white label client. By design, everything is pure Python, everything. There's no other type of code for anything. And securing a long stretch of focus time, really insisting on it, on the planning, communicating it outwards was important. And when I say planning, this is like one of dozens of things we had to plan out what we're going to build well before we started it. I'm not going to expose actual stuff, but it's the actual, but it's kind of grayed out. And then we had the focus time I mentioned. We set up Databricks and the integration, started storage, also on Azure side, VTLs, everything we need. We went about reverse engineering the C# ATLs. I can say were no magic solutions. We used LLMs for translating C# to PySpark. It was nice as hints. It was wrong a lot. We analyzed the code itself, but we also had to inject synthetic data and edge cases to understand if the transformation, we understand the actual transformation like we think it is. So this is part of the reverse engineering, debugging specific cases and having hypotheses on what the hell is going on. And you got to rebuild it kind of like 98% the same way it was, because the CFO will not agree to anything else, and that's okay, he's the client. And then we moved to the period of data testing and the management sign-off. We had both code tests, both independent or unary, so just for the data, the new data, that it makes sense, and a domain expert point of view, and comparative to the old data. And it was hard at one point when we had enough, we had a strong notion we were doing a lot of the stuff better, that the comparative tests started to just not pass, and we had to convince people that this is because the new data is better. A lot of manual analysis by the analyst, the junior data scientist and data engineer, and other people, and the C-levels reviewing it through the end products. That's the point where you migrate essentials before you launch the new systems, because you get the client to kind of like do a data validation over the reports and dashboards. They're looking at the graphs, the things saying, this doesn't make sense. And sometimes it's because you have a bug, and sometimes the old data had a bug, which was both happened often. So it's an iterative process, and then you get a sign-off one day and you launch the system. Some words left the slides. So what are the core kind of components or tools I think helped us in the end get something that works well? So I'll say something about the architecture, but although I think it's quite common, just for you to know, for those not familiar with it, about staging and data tests, about some things our Git helped us do, playbooks and product templates, and workflow cloning. So basically, we have to take data from a lot of not something very unique to our case, taking data from MongoDB and Google Analytics and Azure Blob Storage and Elasticsearch, and get it all into single systems. We had something that that didn't have before, and actually the R&D didn't have, is we actually have daily data dumps that enable us to understand how a data looked at a certain point of time. This is something I insisted on, and maybe a lot of you guys, I guess you notice, when a point in time an ML team gets an assignment, and then say, well, great, let's look at the last 3 years and learn from the labels, and then you find out people have been upserting data into entities that you don't know what the user was like, what he was paying at the time, what was the amount of events, whatever, at a previous time 2 years ago. So you can train the model on what the input feature would have been like 2 years ago if I had the model. And so you have to keep a snapshot of the data every day or every week to be able to do it 2 years ahead. So we insisted on it to be able to do it in the future. We found a way to not press Mongo for performance by taking the insert and upsert data from Elasticsearch, which was nice. Triggered dependent systems like Tableau to take things, data as it is fresh after the ETL ends. And everything, as I said, in this case, we had an easy time, no real-time systems. The most real-time is something that should run every 5 minutes. This is not real-time. So everything is batch, so everything is a workflow. The ETLs building all the data are workflows in Databricks. Tests are workflows, data tests, reports are done by workflows. Model training is a workflow, modeling inference, writing to a output system is a workflow. This is nice. So everything is just pure Python notebooks hosted on Databricks, but tracked by a Git repository. Nice. Schedulable, triggerable by REST API. Way easier for data scientists to handle. This is basically the system. It's very common for a medallion architecture. So the raw data comes. The bronze is really raw data. Silver, everything is flat and becomes a table, but nothing, minimal processing. And then for us, it's Electrum and Gold. You usually see it as Gold and Platinum. There's two less layers is process data. But for us, we decided if it doesn't touch a product, our end product, like a dashboard or report directly, but shared, it's like a mid-level, mid-stage computation product. It's saved in the Electrum layer, and the Gold layer is a layer of really rich, highly processed tables that either a dashboard sits on top, a model sits on top when training, or a report sits on top when generating outputs, or an analysis uses. Okay, so this is basically the system. A core capability which proved key both to the migration and today to working efficiently and enabling juniors to really deliver in kind of speed is having a staging environment, and staging for data science is different than for code. We need a representative sample of data of the system. It's harder than it sounds. You can't randomly sample from tables because you sample random users, random payments, random stores, and just really very small intersection. You got to kind of seed specific tables and spread the seed through the tables. And you got to add to that a lot of corner cases and unique cases that you want to check for data. It's something usually, it's kind of a bit of different than code. So when we get this basically nice sample, and it's hard to do on the raw data. This is kind of shitty. It would be lovely to have this done in the raw data level, but when you get a raw data level staging sample, which runs really fast, but kind of like represents everything, you can test and staging, kind of like data integration test, the whole system, every ETL, every report, every model, through the whole thing, starting from the raw data, pushing a commit into staging branch, deploys it on a staging environment on Databricks that is identical to the production one, just as a really smaller sample of data, and we can see where things crash or don't make sense. And we also have data tests which run on the end of each daily ETL chain and just stop everything that is dependent to work if data tests fail. And like unit tests, data tests are every time you stumble on a corner case, weird stuff. Of course, customer success keep messing with the database and writing custom stuff that our code can handle with, and you gotta write bypasses. You put it into both the staging, so you get it on the staging, and into data tests. So this kind of like a really unit test culture just for data, and this really help. The key rationale here is automating good data practices is crucial for teams made up of juniors. So basically you have daily production data test is a workflow in Databricks. It's composed of suits. Each suit is a notebook, and each notebook is composed of tests, which is just a segment of the notebook. It sets a flag, it sets a message, and then when it fails, you get a nice error, and you can highlight it, and you can jump, and you can see which tests in the suit failed, etc. So you're just providing a nice template for juniors to follow. A nice simple monorepo for everything. Every configuration is on top of it. So all our ETLs are basically configured by JSONs, and notebooks don't hold configuration. This was crucial generally, just to have things trackable, and for the white label, the parameterization of our system, to have it run once on staging, once on production, once on the white label, once on our company's data. With nice environment branches, and we use GitHub Action, not just testing, etc., but also basically on Databricks, your environments are split both in code in GitHub and bound on Databricks by things like init scripts or things that are hosted on the workspace there. So it triggers updates of everything required there to make sure everything we update is also updated on Databricks side, and we get not just code updates. Again, the same rationale. Playbooks and product templates are quite similar, just build templates people can work with. I'm not going to go into this. And the results, because I have 1 minute left, is we got everything that was working previously to work highly scalable. Databricks didn't feel it even. We didn't have to touch the compute. It was just nice PySpark with 4 driver nodes, and it just ate it up. And we are now really calm about scaling up. We have much more visibility about data integrity with daily data tests, which we before were found by users using dashboards and reports. Delivery cycle became really fast. Yesterday, I returned from a day there, And the analyst, the BI analyst who didn't write Python a year ago, did the whole ETL herself. She added tables to the gold layer in PySpark because she had a template, and then she wrote a dashboard and done. She did the whole thing end to end with new stuff and included even some machine learning there. So this is really nice. We had great trust of the data, so actually some financial reports were adjusted backwards when we found a lot of bugs. And it was really easy to deploy the whole system in parallel for the white label clients, which was nice. And we now have a foundation which we already started to act upon to get requirements, more new clients, even from R&D. We now have a system that they don't have. They ask us for things they can do on their data in scale because they have MongoDB and we have Delta tables and scalable compute. We have several new machine learning models in development with forecasting, and we have now a foundation for juniors to just come learn something simple, like forecasting using a Python package, forecasting a time series, and having a template on how to push this into production as a model, writing into a table or writing into something that the dashboard looks at or sending a report. And so for me, the key takeaways here is that modern ML engineering platforms can enable pure Python teams with access to a credit card, independence from existing R&D systems, and I think this is relevant. I'm seeing this with many of my clients. And the second is, if you get one senior to build well-defined habit enforcing systems, then you can have juniors kind of like work within templates and delivering quite well, which can also be a shortage. We now have less of a shortage of senior, unfortunately, but it can help in that case. So that's me. Thank you.